Pierre Drezet, Managing Director at Inx Limited. Thank you very much for your time today. And for those interested in the upcoming Microelectronics UK event, where I'm delighted to say you'll be participating, they'll get to know you and your work a little bit better here. Let's start, I suppose, with a quick introduction. Sort of tell me and the viewers a bit about you, how you came to form Inx, what Inx does, and the pull, if you like, to go your own way and start your own company, do your own thing in this space.
Hi, James. Yeah, thanks for that. So I'm founder, director of INX. I'm a systems engineer background with a focus on machine learning, signal processing, control systems. So been around the block a few too many times, perhaps. And the story of INX's product has really come from my experience as a innovator in tech, really. So starting in the early days of machine learning and signal processing, it's quite difficult technology to deploy, to give to people. And also, as things have become more data intensive, the kind of traditional methods for embedded systems are becoming quite challenged. So I spotted a few recurring problems, integrating technologies, iteration, asynchronous systems, and that built up a pattern. I ended up solving that for myself with a product that's now called Inx Ware, and that's kind of where the market opportunity appeared. If I was seeing all of those issues, then lots of other people would be too.
Okay, great. And you mentioned there that you have sort of 20 years experience building intelligence into embedded systems and IoT enabled products and services. And obviously we're going to be talking about a bit about machine learning here, and I know that your interest in machine learning goes back nearly 30 odd years to your PhD. We've obviously had huge iterations and developments since then. And of course, sort of critically the compute power to back it up, which is, where we are with machine learning, deep learning today. But your argument, Pierre, and you mentioned this with integrating technology to a degree, and I know you're going to be talking a bit about this at the event, is for embedded systems, machine learning has, more than its fair share of headaches. Can you explain to us why that is?
Um, so obviously there's the amount of compute you need to do that is the first one, but it's also that you've got quite a long workflow from building the models, and that's been something that has improved a lot recently. But you were kind of out on your own originally with that. So kind of just going back in time, I mean, it's not quite 30 years. I'm not quite that far down, but so I think I started my PhD in 1997, and in those days, the kind of problems people wanted to solve in machine learning were what I'd call hard problems. So things in medicine, things that need to be as good or better than a human, with small data sets. So all the stuff that's actually still quite challenging today. And also, those kind of problems are the ones which you often get in embedded systems as well. So if you want to do adaptive systems and you want to learn on devices, that was again something that a lot of people were interested in those days. But what happened in the kind of the more broader area of machine learning, which I think everyone learned a lot from, is that there's quite a lot of soft problems. There's quite a lot of data around, and there's quite a lot of commercial use of those in consumer level products. So actually, those platforms became available, so you could do machine learning with a web browser. In the last sort of 10 years, you've been able to log into AWS or whatever you were using at that time, and you would be able to write a bit of Python, potentially purely on a web browser, and you didn't have to kind of get set up. You didn't need to compile code, and you didn't need to have all that aggravation. And the same thing starting to happen now in embedded systems. So companies like Edge Impulse are making those workflows for getting the data into a training environment, being able to output those models into an embedded, optimized format, basically. And produce code as well. So that's been a long journey for machine learning, with more intent. There's been more interest in it than there has been technology development to make it happen. I think that's the lesson I've learned from that.
Absolutely. Is it easy for companies to fall into the trap of thinking that, whatever the use case or application might be, the goal is I need to make my application smarter. There's such a huge ecosystem from big tech and so many ML tools out there and resources out there that there must be a way of getting machine learning to work comfortably with my deployment or use case without thinking of the pitfalls that may fall upon them.
Yeah, I mean that's kind of discovering ways of doing things is you are kind of AI first. That's kind of how things go. So if you want to do something smart and have some intelligence, you tend to be led down a machine learning route. Um, there are, of course, lots of people saying they're using AI without doing machine learning, and sometimes that's for good reasons. Sometimes that's because they want to be seen to be doing machine learning when perhaps they're not. But you do so that yeah, there's not really the verticalization of those problems as much. So if you're doing machine vision, there's lots of machine vision been around for decades that does a lot of what people probably don't expect you can do with machine vision without machine learning. Um, so you are kind of now in a horizontal technology where it's kind of machine learning first, and then you might find out later that you could do that same problem with something that is much more efficient, easier to parameterize, and you don't need to have a large data set to do. So yeah, there's cases where you want to program with data. There's times you want to program with algorithms, and there's sometimes times you want to use somebody else's model you know works. And you need to kind of start from there really, rather than always go for a data-driven approach first.
Hmm. And it's interesting because I know it's another thing that you're going to be talking about at the event to a degree. And you mentioned machine vision and a couple of other examples. What are other sort of alternatives that organizations and companies could have if they want to have this sort of technology, this sort of use case in their embedded systems?
So I mean, in machine vision, there's things like OpenCV, open source software. There's products from companies like Keyence that have been doing industrial vision systems for a long time. Those are very parameterizable things. They're pretty robust. They can be 1,000 times quicker on CPU resources than an Edge ML model. Um, and they tend to be often more robust. So especially when you're building your own from your own data, those models tend to be a little bit more fragile than some of the larger off-the-shelf models. But typically, the most robust solutions, if they work, are those kind of more conventionally coded systems. Similarly, in signal processing and time series, there's quite a lot of statistical methods used for those. There's a lot of standard models that are used that you can extract parameters out of those, so you can learn more than what the annotation of your data set is. So again, that's something you also get in machine vision. If you want to do a medical histology image processing system, you can kind of only predict what somebody's annotated. If you want to extract things like cell sizes out, which somebody's never going to annotate enough for you to learn in machine learning, you can use other transformational methods for doing those as well. So there's quite a lot across the board of and I think for even any machine learning developer, and if you look at how Edge Impulse kind of try to educate people using machine learning, they're doing things like making sure you create the right pattern to space transformations first. And if you understand those, you're probably 90% solved your problem. So yeah, again, that's when you can choose whether you're going to go data driven or algorithm based, and see what works best for you.
Okay, great. Thank you. Before we move on to Inx Ware, which is, as you mentioned, the platform from Inx, I'm interested in your view on TinyML, which is machine learning designed to run on microcontrollers, among others, and enabling models to run directly on embedded devices. We haven't sort of touched upon this too much so far, but I mean, how do you see it at the moment? Where are we at? How mature is it? How do you see it going?
Yeah, I mean, I think the technology's quite mature now. There's a lot of silicon interest, so you can accelerate those with silicon. So there's arguments about things being 1,000 times more CPU intensive and not that much of a problem sometimes. Um, So I suppose the difficulty at the moment is there are lots of different ways of accelerating TinyML, and there aren't that many ways of making the models, which is good, but the way of transforming those models into each of those optimized methods of deployment just for inference are actually quite challenging. So there are, again, mentioned Edge Impulse are good at making some of those transformations for you, but actually you tend to find that you've got a missing step that you have to go off and solve. So there's not really a linear path in that workflow all the time for EdgeML. So our platform is a component-based platform. So if you're using an EdgeML function block, it's the same as some other function block. It could be processing an image, producing some metadata with ML. It could be doing it with OpenCV. They're all pretty much the same thing. The inputs and outputs boil down to the same kind of thing. So what we try to do, and this is an ongoing task at the moment because there's quite a lot of dynamic in that tech space, is make those different types of models deployable on different platforms. So you don't get an infinite choice all the time, but we try and broaden that choice of I've got this model, I want to deploy it to this target, and we'll make that process easier, and we'll be able to integrate that machine learning part with your whole business logic, which is actually where a lot of the intelligence of a lot of products really is, rather than the machine learning itself.
Yeah, absolutely. I mean, you mentioned that a little bit in your last answer, and you said we were going to talk about the Inx Ware platform, which we've kind of been hinting at because it removes all of these headaches that we've been talking about with deployment. So give me the overview, Pierre, if you like, of how Inx Ware came into being, how it works, and from build to deployment, the journey there.
So yeah, Inx Ware was kind of initiated sort of while I was well, in fact, I think I was doing some moonlighting with my PhD in machine vision, and the first version of that was developed to kind of deal with asynchronous, data intensive, which you had to do in C++. They weren't. It was a terrible environment to do that in a smart machine building kind of environment. Iteration's very difficult. So that's kind of where it evolved from, and we developed that. We had a bit of a disaster initially with a VC version of our business. We rebooted the business as a bootstrap business, and from day one, so that's going back to 2008 now. So from day one, the thing that we fell into by luck was that we deployed that for doing IoT systems. So we had a customer come to us with a problem. They had some technology for doing generative media. They wanted to deploy content to that over the network for global deployment for lots of different types of businesses. So we had all the networking stuff, we had all the media processing stuff, we had to build an IoT server at the time, but that was pretty much all we had to do to get that customer shipping their product. And that kind of gave us a software as a service model as well, because we could do that quite cheaply for them. And then we could charge them on a recurring revenue basis. And that's kind of formed the basis of our bootstrapping strategy, combined with a lot of consultancy in other things as well. But that's kind of where the products come from. And so we've sort of built that out with quite a broad range of technology now. So it started off being, so very early on, it was controller focused, then it became more Linux focused. Now it's both, and we've combined both of those tech stacks that you use because they're quite different. But actually, whether you're using a microcontroller or an application processor is typically invisible to an end user of our product. So we've abstracted the hardware. We've made it a systems engineering environment to build in, so that gives you all the detail you need to do anything you can do with code, but it also makes you use better patterns of design, reusing hardened technology that works, has security and has robustness built in. We have a fantastic debugger for hardware and loop debugging, sort of things that are typically quite tricky to do with code. But then on top of that, the thing that we've done most recently is and we've always been open source friendly, but we've taken us a while to actually publish our runtime as an open source project. So if you do need to go and code up your own component, change your components there, or port it to a different platform, you can download it from GitHub. You can make changes. You can even build it on GitHub and do CI on that as well. So it's a cross compilation platform that we've built that makes life easier for technology developers as well, not just application developers.
Oh, well, I mean, that sounds very exciting. Just tell me, was that sort of a long-term ambition that's been realized for you? Was that sort of part of the ethos all the way through?
It was, yeah. And most of the issue with actually making it properly public was just bandwidth of cleaning it up, taking out bits that we shouldn't be putting in there, and those kind of things. So we did most of the work about 3 years ago, and we finally finished it off this year. So that's exciting because that gives a lot less of a lock-in fear you get from OEMs and tech providers who want to, we want people to use this as a way of being flexible, not being locked into platforms, but also letting people who make those platforms extend them without the burden of having to support every single open source component on those as well.
Yeah, yeah, no, absolutely. I mean, so that there is a lot about the sort of theoretical side of it, but if we talk about the practical, the customer perspective, could you give me an example of a sort of a customer story and maybe the kind of the eureka moment, if you like, where they realized Inx Ware was the platform that they needed?
So there's yeah, we've got a few. I think the more recent ones, which we're sort of most present in our mind, are our energy products. So we have a few customers, OEMs, making things like heating systems, some industrial, some domestic, and they typically have a certain level of technical capability, but typically not a lot of embedded software. But they are making products that use embedded software, and they often have to either depend on consultants or third-party manufacturers to kind of do that for them, and they have very little control over that product. So what we've been able to do with that is we've been able to, for the same customer, we've been able to build variants of the same product. So they might work in industrial, but they also supply it to domestic, for example. So we have a microcontroller that's specific to the industrial area. It has a different price point to the one that's going in domestic, but they've been able to use our platform to build pretty much the same technology, just refactor that slightly at the application level, and they've never had to worry about making all these tricky things work, like LoRaWAN or even something as trivial as doing pulse width modulation on some platforms is not great. So making them secure as well. So we've been able to kind of just take that away from them as a concern, because the platform just has that built in. So those customers are deploying with our product very widely. They're able to. So one of our oldest customers in a different space in sort of well-being for buildings, they've pivoted probably 2 or 3 times on our platform. They've pivoted in the hardware they use. They've gone from sort of PC technology to embedded ARM technologies to cost optimize and scale. But they've also pivoted their product, the technology that they fit into ours, which is their own. They've been able to change that platform on a number of occasions so that they can evolve their product and make it work better. And they can just deploy. As an IoT deployment, they can deploy those new applications over the air to all of their devices, which are heterogeneous in type. Some are still PCs, still have some of those for some customers, and some of them are Android ARM processors. So they don't see any of that challenge because we've taken that away with our product. So unfortunately, a lot of our benefits people don't notice, but if we weren't there, they would.
No, that's great. Thank you. I mean, based on sort of what you've just said there in terms of what you're looking at with customers and what you're seeing in the market, a lot of those different sort of smart buildings customers or technologies. If you give me an idea about what that landscape looks like today in terms of, say, product design, technological capability, are we moving closer, or have we reached a point, a sweet spot of capability, speed, and usability in project development? And what are customers looking for?
Yeah, I mean, I think that's an IoT question, probably, is it? More than a yeah. So really, the buildings management systems are kind of a little bit like industrial SCADA in conventional ways, and IoT has kind of broken that schema quite a lot. People can take bytes out of each of those things. They can use different platforms for that. So, but one thing you do see is that they need to be very little overhead in terms of any maintenance. So people don't want to have to interact with it a lot. So they need to be pretty much automatic. So these are things that are pretty much invisible. Sustainability is a an old favorite for those things. Well-being is another one, and there's also going into some of the medical side of things have the same infrastructure kind of buildings management stuff as well. So yeah, these things need to work without people knowing they're there, really. People don't want to log into a dashboard every day and check stuff. So we typically make things which are active devices rather than just sensors as well. So and if they stop working, people notice quite quickly in buildings, and so they have to be very reliable. So I think what we see is that if you make good IoT products, you don't need truck rolls. You don't need the costs of service providers to do that. People can manage them themselves. And again, building those systems out for very specific parts is actually where, rather than having one buildings management system that does everything, seems to be the way things are going in buildings.
Okay, great, thank you. Inx is sponsoring the Microelectronics UK event in September, an event which will be the first of its kind. What are you going to be doing at the event? And I appreciate we've spoken a little bit about this and sort of weaving your previous answers in, but what are you going to be doing at the event, and what message will you be looking to get across to attendees at Microelectronics UK? Yeah.
Yes, I'll be speaking on day one with analog devices and edge impulse. So we'll be talking sort of probably quite widely about embedded systems, but there'll be a machine learning aspect to that. So format of that to be defined exactly, but there'll be a bit of a discussion area of that, which we'll be looking forward to fielding questions, finding out what other people are doing in that space. And then on our stand, we're going to demonstrate a mixture of some sort of products that we've made with our product, showing how they work, showing the whole IoT end-to-end system. Hopefully the networking will be sufficient for doing IoT things. It's often challenging. But we'll also be showing some more under the bonnet tech demonstrations. So we're going to be showing some machine vision in a closed loop real-time control application using a Raspberry Pi. So we've got an intern who's been working on an inverted pendulum problem. My control engineer background's got the better of me this time, and so we're doing that, which is quite a fun physical demonstrator, and it's really there to show the differences between how efficient you can do machine vision and switching between machine learning and non-machine learning methods, and also using acceleration for machine learning methods as well. So it'll be under the bonnet. You'll be able to have a look at code, be able to have a look at our live debugger, where we can get all of that data out of devices that are running, and also how you build an application with Inx Ware from scratch. So there'll be a bit of fun stuff as well. We're probably not going to bring out as much of our fun stuff as we normally do. We don't have a huge stand.
But plenty to be getting on with in the meantime.
Yeah.
I mean, final question, Pierre. This is almost the crystal ball question, if you like. With regard to, and again, I suppose people will be asking this at the event as well. What are we going to see for the future of embedded systems? What does the future hold? What do you think the next 12 months are going to look like in terms of this space?
Well, I think integration is still the problem, and I think that's the problem that people are facing up to now. So the platforms that are normally used to solve those, we're probably going to see some of those win and others not win. And I think really, the next level of innovation in embedded systems is to get devices to do more than one thing. And that's where integration becomes the barrier to entry for many smaller businesses. So we hope that we can help all those smaller businesses and the larger businesses economically build products that they've shied away from in the past.